All right. Next up, our last speaker, Karen O'Brien. She is a senior principal data scientist at Modern Tech Solutions. And in this capacity, she leverages her 20-year Army civilian career. Previously, she worked at ATEC, and she's done a range of different analyses from ballistics to logistics, kind of all over the place. Karen also has an MS in Predictive Analytics from Northwestern, and she is the co-lead of the Women in Data Huntsville Chapter. So please welcome our last speaker.
Thank you so much for attending, and thank you so much for the opportunity. I love DataWorks. This is a wonderful little gathering, and as I was struggling with the title, I used to have an office right across the hall from Shane, so I really understand his sensitivity to language. I didn't want to call this DOE, so I did settle on test science and reflected a little bit about this journey of advancing test science in the DoD for operational testing, developmental testing, and so forth. And it's been a long, long journey, at least 15 years. And a lot of people have been battling to gain ground and raise the bar on how we approach testing in a scientific way. And so my preamble, I do one every year, is my favorite patent quote ever, which is, "Never yield ground. It is cheaper to hold what you have than to retake what you've lost." So my appeal to the T&E community is, we've made so much progress in advancing test science over the past 15-ish years. Hold the ground. Hold the ground. Continue to maintain an expectation for scientific rigor for testing AI-enabled systems, because we have to. There's really nothing about this new technology that means we don't use our test science. So I hope to challenge some assumptions. I might say something provocative or horrifying. Hold on to that feeling a little bit, because that's perhaps an assumption to challenge. And I'd like us to step away from the assumptions that we bring to the table about testing AI-enabled systems, specifically LLM-enabled systems, examine those assumptions, especially with respect to benchmarks and little metrics like accuracy and F1, et cetera. We can use our scientific test and analysis techniques on these systems. And so that is my 30-second summary of my 20-minute summary of a 50-minute summary of approximately a 3-hour workshop. So there are many, many rabbit holes that we encountered on this, and we're so happy to sit and explore those with you outside of this session. So yes, my name is Karen O'Brien. I work at Modern Technology Solutions now. We are a 100% employee-owned engineering services firm who supports DoD customers. Test and evaluation is one of our core capabilities, and so we were called upon last year to do a test and an evaluation of an LLM-enabled system for one of our DoD customers. Now, we can't release those results, but that's okay, because we can talk about the methodology that we used, and that's what this presentation is. There is with this a very large literature search, so that's in the backup. Those documents were so helpful in helping us challenge our assumptions and figure out how we're going to proceed to really meet the stakeholders' needs, understanding what they wanted to get out of this LLM-enabled system. So that's in the backup. A lot of the slides from the longer version of this presentation are in the backup. The workshop-y version of this presentation has an interactive component where you can crack your knuckles and fire up your favorite LLM-enabled system and try out some of these ideas, things like sycophancy and the reverse curse, and some of these things will really show up in the experiments you do with these systems. So this afternoon, we're going to be presenting a poster where you'll get more information about this model, but our approach to testing AI-enabled systems is looking at this idea of calibrated trust as that top-level thing we want to get to. Calibrated trust is Goldilocks trust. It's just right. Not too much, not too little, exactly appropriate trust in a dynamic world. So moment to moment, can we calibrate our trust in a system based on the environment? So central to that are some evaluation questions. Like fundamentally, we almost always want to know, does a system successfully do what we want it to do? Yes. And so most of the benchmarks and evaluation metrics that you see for LLM-enabled systems, they focus on this. Does it do what we want it to do? We tend not to put as much emphasis on this other question because in testing hardware and software, we don't think about this too much. Does it successfully not do all the things we don't want it to do? And when you sit down with a stakeholder or an end user and really start listing those out, you can generate a really big list of testable topics. Uh, can we show that the system successfully doesn't do all the things we don't want it to do? We don't want it to make stuff up. We don't want it to give us the wrong answer. We don't want it to remember things it's not supposed to remember, like Monty Python. That happened. So sitting down and building this into our test design is an important part of it. And of course, we want to make sure it successfully does and successfully does not do those things across a wide range of operational conditions. We're going to focus on this RAG configuration. These LLM-enabled systems, there's a spectrum of complexity. So on the far simple side, we have our basic chatbot, where you're asking questions to an LLM, just talking to the model, the base model there. On the other side, we have much more complexity. You have this idea of agents, where they're out there doing all these things and deciding if they're going to call a calculator, if they're going to call up a dictionary, or so that's another end of complexity. We'll work on agents next year because I have some ideas for testing those. So we're going to focus on RAG, which is retrieval augmented generation. It's kind of a midpoint of complexity. And the idea is you have a system, you have modules that work together to support the end user. So you would have an LLM component. You would also have a search module of some sort, lots of different technologies there, and then a corpus, a collection of documents or resources that the system is going to use. There are dozens upon dozens upon dozens of versions of this, so it's absolutely critical to get a diagram of the architecture of the one thing that your stakeholder wants to use. And so because of that, there's really nothing in this presentation that's prescriptive because every situation is going to be a little unique. Your stakeholder will have their objectives. The vendor will have their own version, their own architecture, their own stack up. So it's hard to get prescriptive here, but understand that every node in these architecture diagrams is testable. They can succeed or fail at doing the things we want them to do or not doing the things we don't want them to do. And every one of those arrows is also something that is testable. Is this handoff between modules happening correctly or not? So this diagram ultimately is an important part of designing a test. Okay, factors and conditions. This is where I frustrate Shane a little bit by using my imprecise statistical language. I try not to terrorize my non-statistician stakeholders, so I'm a little loosey-goosey with my terms. Please forgive me. But whether we're doing a simple test or a very sophisticated test, it really does boil down to controlling the variables that impact the outcomes. So in DOE parlance, we tend to think of factors. Factors are those variables that impact outcomes. Sometimes they're independent, sometimes they're dependent. These, some of them can be controlled, some of them can just be observed. All of that is important for doing the experiment you want to do because you're allowed to do that experiment, and I'm begging you to do the experiments. Levels, this is a more formal version looking at the different values that the factors can take on, can be quantitative, can be qualitative. Now, when we use non-terrifying statistical language, we also refer to conditions. Now, the statistics textbook will say, well, those are like thresholds that the data has to meet in order for you to accept it for the analysis. Okay, but we also talk about conditions as a very user-friendly way to understand what those levels are. Because it's one thing to say we're going to test in the desert at 150 degrees, but if you say we're going to test at Fort Irwin in August, people get it, and that's very understandable, especially for our military warfighters who've been out to Fort Irwin. By golly, that's hot, you can relate to it. So it's just a way of discussing levels in a way that's easier to relate to. Now, might be a little obnoxious, but what we are talking about here are the components of a school science fair. I'm not putting this up to offend anyone and say your marvelous statistics degree really just boiled down to science. But there are some amazing things popping up in the literature right now. Experiments, really simple, impactful experiments that are not any more complicated than what you see at a middle school science fair. I have two of them in here that are just tremendously inspiring. And there's a data visualization that goes with them that are just so easy to do that you have to kind of work hard to come up with excuses to not do the simple experiments. So what is the hypothesis? What are you trying to test? What do you want to measure? You can measure these things. You're not limited to benchmarks. And honestly, there's not many benchmarks that will help us answer questions that are impactful in a military operational environment. Okay, factors and conditions. When do you use these? You can use these in experimental studies. We're not limited to DOE. We can do A/B testing. We do replication studies. We could do scripted testing. There's also on the other side of the fence, we have these things, these observational studies, where we're not controlling quite as many things, but we're going in afterwards, tagging and coding the things that we do observe. And if this is less familiar to you, I strongly recommend reaching out to your friendly neighborhood HSI practitioners because they do this kind of stuff all the time and they can help you. And ultimately, this is critically important because you can plan all day and then test happens. Your warfighters show up, chaos happens, they do what they do. And if you've been at an OT, you know something unexpected happens every single time. And every single time something unexpected happens, you have to go figure out why that happened. What went on there? What does this mean? So this practice of going and tagging and coding the things that you have observed comes in very helpful for explaining what happened on a post hoc basis when something crazy happens in test. All right, super categories. Now in the backup, we have a drill down on all of these, but these are things that impact the outcomes of your LLM experiments. Your humans vary a lot. They vary by role and experience and preferences. We were talking a little before this session about prompt engineering. No, humans are going to human and they're not going to prompt engineer very much, even if you train them to. So understanding that your humans are going to be humans and interact with these systems according to their preferences, that's something to either control or observe in your experiments. Humans do all sorts of wild things like making assumptions and leaps of logic, and being able to observe and tag and code those things is an important part of analyzing what happened in your experiment. Tasks. Now, there is a world where these become kind of the response variables, but this is also a world where these may become individual experiments. So I wasn't sure how to bundle these in as like the factors or the conditions, but ultimately we ended up doing a bunch of different experiments to explore different tasks. So it's important to look at them, think about them, and decide how you want to approach them experimentally. Some tasks might not be feasible, especially given all the Imagineering that surrounds this specific technology. We imagine it's going to read all of these news articles and tell us what Putin will do on Wednesday. Probably not feasible, but worth testing because we want to understand its strengths and limitations. Okay, the documents. Now, a RAG, a corpus, is usually composed of documents, not always, but these vary a lot. And so it's important to engineer an operationally realistic corpus to do your testing on. And they need to include all of the non-text stuff, like the 3 and 4 columns of text, all of the decorative things, all of the pictures and the diagrams and flowcharts and tables, and some of the tables are OCR and some of them are turned sideways on the page. These are things that humans navigate, and they need to be in the corpus. Okay, the system we're going to hold on to, and then the answers, these get interesting. The number of hops, how much ambiguity. There, again, in the backup, we have just a ton of rabbit holes on these. And the answers themselves may be infeasible or inconsistent. All of that's going to matter to your end user. And so building those into your design is really very important. Now, when you go down the rabbit hole on each of these, you're going to see an overwhelming number of things to think about. And you could very easily end up with an infeasible test situation. So you will have to make some decisions, let some things go, control some things, prioritize others. But at the end of the day, when something inevitably weird happens in OT, you're going to have to go back and investigate all that on an ad hoc basis. So it's worth knowing that these things exist. They're out in the wild. If you can't control them, at least understand them. Okay, moving fast here. So when we sat down with our stakeholders, We had a DoD role. I redid this to be not so DoD. So we have a staffer. Staffer does these things, does research, looks for information in a variety of documents, looks at the current news, looks at trends, and ultimately composes succinct responses for material. So every action officer everywhere, you find these folks in headquarters, you find them in G3s and G4s. They have to be correct every time or else they're going to have to find a different job. So decomposing the things that the humans do into tasks, now you're going to see where these little individual tests come from. So identifying the tasks that we expect the LLM systems to perform, the frequency of these, how often do we really have to synthesize briefing remarks for the director for congressional testimony? Monthly? Every 6 months? So there's a frequency there. In interpreting these things into constituent cognitive tasks, there may be other ways to bend them, but we looked at them in terms of cognitive complexity, and we provide some literature to how to think through that. We chose rack and stacking them against Bloom's taxonomy simply because it was easy to explain to our stakeholder. There's probably more rigorous ways to do that. Your mileage will vary. And then inventory and analyze the documents and pull all of that together. And so these are the bones of the experiment. Okay, so let's suppose this is our list of tasks that our humans are going to do pursuant to their job as a staffer. And they're going to go find facts, they're going to list things, they're going to summarize, they're going to proofread. There are some errors in this because we failed to proofread completely. So apologies for that. Search and research. Now we get into some interesting things like temporal reasoning. You want the most current version of the bill or the most current version of the policy, not the one that's obsolete by 20 years, right? So there's a temporal understanding what's recent, what's today, what's next, what's past. Things like financial reasoning. Has anyone looked at the J books? Oh, okay, we've got some visceral, like, talk about tables inside tables inside. There are unnatural things that tables do in the J books, and humans go and use those every single day. And Congress uses them. So you want to put some J books in your corpus because that's a really fun, challenging format. Okay, so what we did is we stacked these up against Bloom's taxonomy. And ultimately, we did a bunch of different experiments at these different levels. These are not the same. So if someone comes in and says, my LLM is awesome, it has 90% accuracy, according to some benchmark. And if I know something about that benchmark, and I know that benchmark was really limited to these low-level cognitive tasks, like go define a word, or finish this sentence, or find the sentence that talks about this, I believe that. So those low-level cognitive tasks, those remember-level tasks, 90% I could do that. But if we now say that same LLM is 90% at legal reasoning, I do not believe you. I'm going to call that an extraordinary claim, and I'm going to demand evidence from an experiment designed around legal reasoning because it's different than going and defining a word. So this ended up being very important for us. Your mileage may vary, but ultimately you might find the line where performance really starts to fall off, where performance is advertised from benchmarks really isn't quite cutting it, especially at that synthesized level, where you're creating a new document that's harmonizing with talking points. There are some humans who are really good at that. Maybe the LLM is, maybe not. Should test that and probably see. Okay, so now if we go look at some of those other factors, you're going to want to develop levels within them. So here's an example. This is one of like 100 rabbit holes. Let's talk about typos. I'm awesome at typos. I make them all the time. So this was a fun topic for me to go learn about all the different kinds of typos. Who thinks about this? Well, I did in April last year. Anyway, learned a lot about typos. But this is an example of how you can say, okay, I want to see how the system does with error handling. I want to make sure it doesn't handle typos incorrectly. I want to make sure it's going to give me good answers in spite of my typos. So you can develop levels around how many typos. Just one? I'm an overachiever. I can do many in one prompt. Which word? Completely random? Or what about a drop word or a stop word, the word like the? T-E-H, misspell that one. Well, that one really doesn't matter much to the language models. But if you misspell a key term, that might matter if there's a maximum similarity function running and it's looking for that exact match. What kind? Atomic typo. I learned about this. This is a correctly spelled word. That is not the word you intended, but the spell checker is not going to flag it as a misspelled word. There's one of those in this presentation. A phonetic error. I mean, think about this, especially with our acronyms. How do you spell Sinwitty? That's an acronym. It means a lot to DoD. Eek. Well, you're going to need to get that information. Might have to go Google that. I don't know, because keyboard flubs. So what you can do is develop these question-answer pairs with a typo and without a typo. And now you can do a simple little A/B test and see, does error handling really matter here? So here we have what is polystyrene, just with a generic phonetic misspelling. An atomic typo, like what I meant, what country produces the most plastic, but I typed in what county. County is not misspelled, but it's not what I intended. And then there's the keyboard flub. Yeah, Google can handle a keyboard flub for what it's worth. And so how do you score results from a typo? Right? Is it successful if it correctly interprets what you meant? Is it successful if it comes back with saying, I don't know what you're talking about? That's actually a really safe answer. I don't know is a great answer. So it gets us out of this whole binary thing. Oh, it's yes, it's correct, or zero, or it's not correct. Trying to be sensitive to time, and I apologize for going so fast. But as you dig into these, your humans, they are going to prompt the way they prompt. Remember Google's advertisement last summer with the little song and dance number? Just prompt your prompt in the prompt bar. There's no wrong way to prompt. It really didn't catch on, but it was a clever little ad. They're going to bring their assumptions. They're going to bring their slang. When they say reg, they might mean law, they might mean policy. There is a difference, right? The tasks, make sure we have a good sample size. I've become a huge fan of sample size. Just go all into sampling this like it's a presidential poll, get a lot of different samples from a lot of different things. The documents, engineer a good complex. It should go without saying to hold the system constant. You're going to have to say that to your vendor. Hold it constant. And then a lot of variety in the answers. So I'm going to start skipping slides now because I am sensitive to time. The benchmarks. Let's take a moment. So the benchmarks, be really careful with these. They're easy to produce. Anyone can produce them. You get a sample of first graders together, come up with what they think is really hard questions, and poof, we have our first grade equivalent benchmark. Absolutely anyone can put these together, and they're fine for comparing benchmarks or models to each other, but they don't really translate well to the military operational environment. They don't generalize well, and there's a lot of documentation on this. They're subject to contamination. The LLMs do really well when they've read the test and the answers before you go ask them the questions, right? So in general, a lot of times the benchmarks don't have subject matter expertise. We're hearing a lot of claims about reasoning, but there's not a single cognitive scientist on the team developing the benchmark. And this really came to my attention when Stanford wrote this wonderful paper that I highly recommend. It's the Better Bench Assessment for how to crack into a benchmark and evaluate it. And because I'm kind of negative on benchmarks at the moment, I wanted to share a good one. It's called Legal Bench. It has sample sizes in it. It takes that legal reasoning and it builds like some little categories of different reasoning tasks, and there's a nice sample size in there. 27 instances, so you can now compare this kind of legal reasoning to this kind of legal reasoning, and they give a little p-value to tell you it was great. So that's a good one. So strongly recommend building your own rigorous and reusable test that's tailored to your specific situation. Don't depend on benchmarks, but if your evaluation is crying out for an experiment to generate answers, do that experiment. You are allowed to do that. And it's easier when you have a good sense of the factors and conditions that can drive outcomes. Like I say, this is about an hour and a half of rabbit holes to go down. We have so much to share, and I'd love it if you're interested in this topic, please reach out, follow up. We would love to come to your site, talk more about this. We're also going to be at the poster session this evening to talk more about our conceptual model for testing AI-enabled systems. And I'm sorry for skipping over so much, but we've got some adversarial methods in the backup. We have fun with Bernoulli and all of those terrible assumptions. There's a lot of nuance in scoring. Would love to share more, and I'm sorry that we're out of time. So maybe do some questions.
Questions for Karen?
Hello, Frank from IDA. I thought this was a really interesting talk. I really thought the way of applying LLMs to the Bloomberg taxonomy was really interesting. Were you able to find different insights for the different levels? I was curious.
Anything related to reasoning. Anything related to reasoning, we had a lot of unsuccessful answers. So if you ask a reasoning question, it says, I don't know, that's a successful question. But if you ask a reasoning question and it just makes up some weird thing, that's not an acceptable answer. We also saw a lot of variability. I'm going to go bounce into the backup slides. So the further you get away from the low-level cognitive scores, the more variability you see in the results. Where did that slide go? Well, so the higher up you go in reasoning, the further up the taxonomy, you get a lot more variability. If like you ask the same question 30 times, 60 times, it's going to bounce around, give you unique different output. If it doesn't flip-flop, if it stays mostly correct the whole time, that's successful, even if it's variable. But you'll find that sometimes it does flip-flop and give you a wrong answer where previously it was correct, or vice versa. So the more you get into those reasoning tasks, the more variability you have, and that might not be acceptable for your stakeholder. Okay.
Karen?
Flip-floppy. Yeah.
Hi, Karen. A great talk. Did you fit any statistical models to these things and use that sort of find any like factor levels and report that as part of it? If you had like a DOE where you had a pre-existing design and then you took that and then fit a
I
model
had
to it?
great ambitions for a DOE. And then I learned just how deep some of these rabbit holes go. And I realized, given the time we had, we weren't ready to do a very rigorous DOE. That's the whole flashy get off the stage thing. So we had great ambitions for doing that. Ultimately, we ended up with, we converged on some Bernoulli trials. We built small experiments built around a sample size of interchangeable questions, and we looked at simple things like recall, like list, like summarize. And so I think we're on a path to greater things, building more sophisticated design. But once we realized just how complex this could be and all the different things that really impact, we realized we didn't have enough awareness to control all the variables that would matter.
Thank you.
Okay.
One from me, I'm just curious, have you seen benchmarks or measures that differentiate between like LLM response, the truthfulness of the response versus like the utility of the response? Because models can say things that are true, but that's not useful to me sometimes.
Right. And that's where we get into, I mentioned those like middle school science fair experiments. Here are two very simple examples. One was by the BBC, the other one was by Columbia Journalism Review. And so these were summarized tasks. Here is an article, summarize the results. So BBC did this, and they had a jury of experts score them to include things like truthfulness, accuracy, things that really mattered to that organization. Columbia, this is an assessment of confidence, confidently correct or confidently incorrect. I love both of these for the data visualization, but ultimately this is a simple experiment. You have a task, you repeat it a bunch of times, you have a jury score the results, and you can tailor it to what matters to your experiment, what your evaluation objectives are. I know there's a bunch of benchmarks that do that, and I know we're out of time, But ladies and gentlemen, they teach Bayes' theorem in your very first stats class, and I challenge anyone to find in the literature a systematic expression of conditional probability when you're using LLMs to score other LLMs. It scares me, and I'll buy a cup of coffee if someone can show that that Bayes' theorem is well understood in conditional probability in scoring these things. I'm not a statistician, but dang, I did take that course, and it just jumps right out.
Thank our speaker one more time. Thank you.
Thank you.